What's up, guys? I just got done filming that impact test video. These are the numbers I got for the rubber steel balls. So I have a balance at my work that's pretty accurate. It goes 5 digits over, but it takes a while for it to balance itself if I have an extra digit on all of these. So it would be like 2.55610 or 2.57768. Like it's very, very, very accurate. I just set it to 4 digits though, so I can get a faster reading. The rubber steel balls, they had the biggest difference in out of the sample size I did, which was just 10 balls. They had the largest difference in weights. So the heavy ball was 2.6754 grams, and the lightest one was 2.4834 grams. So that difference was 0.192 grams, like off from each other. So almost 0.2 grams difference with that 10 ball sample size that I had. And all of them together weighed 25.75 grams. So each of them weighed about 2.57 grams. I'll just calling it 2.55 average, 2.5, 2.6 grams. If you want to, get rid of all these extra super specific weights, so you just round up. So 2.6 grams, 2.55 grams, whatever you want to, however you want to decide. So yeah, they're kind of all over the place. The T4E rubber rounds, they weren't off very much compared to the steel rubber balls. So this is like 4 times more precise. And they weighed, 1.14, 1.15, 1.16, 1.16. The biggest difference was 1.16 and 1.12. So 0.04 grams difference from the heaviest ball and the lightest ball. So it's not that big of a difference, but there is a difference. The high and low. So I weighed all of them together, and they weighed 11.55 grams. So the average is like 1.15. They're pretty much 1.1 grams. The Alien Play aluminum balls, the 50 cal ones, they were very, very close together. The difference between the heaviest one and the lightest one was 0.0067 grams different. So out of the sample size, I just picked 10 random balls out of the bag that I have. The lightest one was 2.70 grams, and the heaviest one was 2.714 grams. So yeah, that's the difference between the heaviest one minus the lightest one. It was just that much different. So I feel like those Alien Play balls are what, at least the batch that I got and the sample size that I did, it reflects that they're made pretty well and very consistent. This was the average weight on them. So yeah, they're pretty much 2.7 grams average. They're advertised as 2.8, but they ended up, for me, this batch that I got was 2.7. These are advertised as 2.7 grams. Like if you look on the Amazon page, it says 2.7 grams, but mine were 2.57, 2.5, 2.6, like average weight. So it's all going to change. Like if I buy another set of Alien Play aluminum rounds and I do this test again, it's not going to be exactly that all the time. And then the orange Lambid nylon balls, those are pretty tight too. So this was the difference between the out of the 10 balls that I weighed, this was the difference between the heaviest ball and the lightest ball. So it's basically 0.01 grams off. That was the heaviest ball, and this was the lightest ball. And this was the average out of all 10. So all of them on the balance at the same time was 14.3208 grams. And then if you just divide this number by 10, you get that. So yeah, they're pretty much 1.4 grams. And these are the hard balls that are, like they're dense. There's no pockets. There's no mixture of rubber or steel in them. It's not made out of rubber. So it's kind of more obvious to me that these are going to be more consistent as far as like the heaviest ball and the lightest ball out of the sample size that I chose. So yeah, there's not much of a difference on these. The more the balls that had more of a difference were the rubber steel ones. They kind of reminded me of the steel coated rubber, the steel rubber coated balls I got from Riot Ball. They're like 10.9 grams, but I had a really huge fluctuation in weight difference between each ball. Those are 68 caliber, but yeah, these are the weights. This is basically the average, and yeah. So I made a new like cheat sheet with a 2.55 gram weight and FPS readings and joule numbers. So I'm just going to refer to these in my videos instead of like using my web browser and going to that. It's like calculator soup or something like that. Some sort of kinetic joules energy calculator thing. And then yeah, I'll just use these papers to reference where I'm hitting with whatever rounds I have. So these are for the rubber, steel, and the aluminum. And then this is what I thought the alien plays were, but they're not. So I'm just going to cross this off, or I'll keep this here just in case I get a batch that is actually 2.8 grams, but I can not use this anymore. 1.1 grams. These would be the T4E rubber rounds. Have all the FPS readings, all the joule readings, and then these would be for the 1.4 gram nylons, all the FPS, all the joules. And then I have this same stuff for the 68 caliber stuff that I have. So this is the Bernaz and kind of like the T4E rubber rounds, 68 caliber. This is for the those pink Lambid 68 caliber balls that I have. I would do a 3.7 gram, but it's very, very similar. Like it's probably like 15.2 joules or 15.3 joules, you know, with all these numbers. So you could just add like 0.1 or 0.2 joules onto these with a 3.7 gram ball, which is the salt supply ball. And I don't have very many of those, so I didn't even make a column for 3.7 grams. 7.2 is the alien plays, and this is all the FPS and readings I got, or, you know, FPS and joule readings, what it equates to. And these would be the 10.9 gram Riot balls that I have, and the joule, the speed FPS, and then the joule rating equivalent. But yeah, the rubber steel balls had the biggest difference in the sample size I did, and the aluminum alien play 50 cal had a very, very tight, very small difference between the heaviest and the lightest. So yeah, I'll post these pictures on my community page. But anyways, have a good one.